Okay, today we'll discuss about one problem which was appeared in the NET examination in 2018 June, and question number 71. So here the question is something like that: the dispersion relation of the electron in the conduction band of a semiconductor is given by this relation. So dispersion relation, which is actually the relation between energy and the momentum, and this is something written something like that. E versus k graph is known as the dispersion graph, and the dispersion relation is given something like that. And omega c is the cyclotron resonance frequency of that conduction band electron in magnetic field B. Then what, find out the value of alpha. So we have to find out the value of this alpha. And what is given, it is given that these electrons moves in a cyclotrons and which has a resonance frequency omega c. So now look at this, the concept of the cyclotrons. In the cyclotrons there is a 2D-shaped path, and the electrons moves in this D-shaped path, or in this circular path. So when the electrons which are charge E and moves with velocity, let it moves with velocity v, and in a magnetic field B, then there will be a force on the electric in the electrons, on the electrons. That will be, this force is known as the Lorentz force, and Lorentz force is actually QVB sin theta. Here sin theta is 90 degrees, so it will be VB. And but we know that this force is nothing but the centripetal force. Okay, r is the, let it be the radius of this circular path. So this will be evb. Okay, then we have to cancel out, and which is mv by r is equal to eb. And but we know that v is equal to r omega. Here we can put omega is equal to omega c. Okay, then m r omega c is equal to e b by r. So from this expression we can get that omega c is equal to e times b. Okay, or you can say that omega c is equal to eb by m. Okay, but you see here this m is not the mass of the electrons, it is the effective mass of the electron. Effective mass of the electron, because when the electrons moves in a conduction band, it's actually feel the force due to the other electron present in the conduction band, and also from the lattice. Okay, lattice ions, and that's why its mass will be get changed, and this mass is effective mass. And we know how to calculate the effective mass. Effective mass is nothing but actually m star effective mass is nothing but h square by double derivative of E with k square. Okay, now you can calculate d square E by dk square, which, because the E is actually E0 plus alpha into k square. Then if you calculate d square E, if you calculate, just wait a minute, if you calculate this E d square E by dk square, then this will be 2 alpha times k. Okay, sorry, 2 alpha, not k, this double derivative will be 2 alpha. Then it will be h square by 2 alpha. Then I have to put the effective mass here. Actually this is not mass, this is effective mass. Omega c will be eb times h cross square 2 alpha. Then we have to find the value of alpha. Alpha will be h cross square omega c by 2eb. Then our alpha, which is a constant, will be value this one. Okay, now look at the options. And here there is a option something like that, h square e omega square by 2. Now this is the right option.